गुड इवनिंग। तो हम जो है एनसीईआरटी के इंटेक्स्ट क्वेश्चंस कर रहे थे जो कि बोर्ड में मोस्ट एक्सपेक्टेड क्वेश्चंस होते हैं। सीबीएसई बोर्ड एग्जाम में उनमें से क्वेश्चन आता ही आता है, ठीक है। और हर क्वेश्चन जो है 1 मार्कर होता है। मोस्ट ऑफ द क्वेश्चंस आर 1 मार्कर इन पी ब्लॉक एलिमेंट्स, ठीक है। तो लास्ट लेक्चर में वी हैव कवर्ड 7.1 टू 7.12 12 क्वेश्चन हम कर चुके हैं और आज हम करेंगे 13 ऑनवर्ड्स। सो 13th क्वेश्चन इज, I think it is better to turn off this light. ठीक है, 7.13। ओके, तो क्वेश्चन नंबर 13 हम करने जा रहे हैं और क्वेश्चन है व्हाट happens when concentrated H2SO4 is added to calcium fluoride और सेकंड क्वेश्चन है SO3 is passed through water. SO3 वाटर। ओके, सो अपने पास ये दो क्वेश्चन हैं। इस 13 क्वेश्चन के दो पार्ट हैं कि व्हाट हैपेंस व्हेन कंसंट्रेटेड H2SO4 is added to calcium fluoride and SO3 is passed through water. So you know, concentrated H2SO4 when passed through calcium fluoride and you know H2SO4 is associated through hydrogen bonding. It is a very viscous liquid. It is least volatile. It is less volatile. So it can easily react. And you know calcium fluoride is calcium 2 plus 2F negative. So in this way we get calcium sulfate along with 2HF. You know HF is more volatile than H2SO4. Therefore, when this displacement reaction takes place, then it can easily remove this more volatile HF. HF is more volatile. Being more volatile, it is easily removed from the reaction mixture and therefore reaction moves forward. So when calcium fluoride react with H2SO4, then we get calcium sulfate, say calcium 2 plus SO4 2 negative and F negative H plus. They give HF and calcium sulfate. Done. Next, second part is SO3 is passed through water. So you know SO3 is anhydride of H2SO4. When SO3 is passed through water, it will give H2SO4. So we call SO3 as anhydride of H2SO4. What it means? कि when water is added in SO3, it will give H2SO4. So that's why SO3 is called anhydride of H2SO4. Likewise, CO2. CO2 is anhydride of H2CO3, carbonic acid. Okay. Same P2O3, or we can say P4O6. It is anhydride of phosphorus acid. P4O10. It is anhydride of phosphoric acid. B2O3 is anhydride of boric acid. You can balance them. So anhydride means any oxide of an element which when dissolved in water, that will give that particular acid, like boric acid, phosphoric acid, phosphorus acid, carbonic acid. Likewise, SO3 is anhydride of sulfuric acid. So when SO3 is passed through water, it will give H2SO4. Done? So this is question number 13. Okay, who is new? Okay, welcome Bhuvnesh. And thank you guys. Subscribe it. Free Fire 5911. Thank you so much. Okay, next question is halogens have maximum negative electron gain enthalpy halogens have maximum negative electron gain enthalpy. Explain why. Okay, so why halogens have maximum electron gain enthalpy? Because as we go along the period, size, as we go along the period, size decreases. And what about nuclear charge? Nuclear charge increases. And at the same time, halogens have electronic configuration ns2 np5. Halogens have electronic configuration ns2 np5. So just one electron, if added to it, when one electron is added to them, it becomes ns2 np6. These are halogens and these are noble gases. Nowadays it is not known as inert gases, they are known as noble gases. Why not inert? Because they are not at all inert, because they can react, but they are least reactive. For example, xenon and krypton, they can form compounds with oxygen and fluorine. That's why nowadays name has been changed from inert to noble. So that means halogens acquire extra stability after gaining one electron. So what we write? Halogens is on the extreme right before noble gases. So leave the noble gases, then halogen is the element which has the least size. They have small size, or we can say smallest size in its period. They have high nuclear charge, and they acquire noble gas configuration just by gaining one electron. That's why they have maximum negative electron gain enthalpy. Because what is electron gain enthalpy? Amount of enthalpy change when an electron is added to an isolated gaseous atom. So when one electron is added to halogen, they acquire noble gas configuration. So they become more stable, or we can say they become extra stable, and that's why their electron gain enthalpy is very high. Okay, so negative means energy is released. Obviously, when halogen gain one electron, they acquire stable electronic configuration, so energy is released, right? And that's why halogens have maximum negative electron gain enthalpy. You will write like this: कि halogens have small size, they have high nuclear charge, and they acquire noble gas configuration just by gaining one electron, and that's why they have maximum negative electron gain enthalpy. Done? Okay, so this is question number 14. Now question number 15. Question is, although electron gain enthalpy of fluorine is less negative as compared to chlorine, fluorine is the a stronger oxidizing agent than chlorine. Why? Okay, so question is, fluorine has less negative electron gain enthalpy than chlorine, and you know why? Because fluorine has extremely small size, very compact, therefore there is large inter-electronic repulsion for the added electron. The electron which is added, that feel more repulsion. Okay, that's why electron gain enthalpy of fluorine is less than that of chlorine. But even though this is the thing, but fluorine is stronger oxidizing agent. So what is oxidizing agent? Which can gain electron, but in aqueous solution. Electron gain enthalpy is in gaseous state. Difference, see the difference. Electron gain enthalpy means the element which can gain electrons in its gaseous state. But oxidizing agent is the one where electron is gained in aqueous solution. That is the basic difference. That's why there is a difference in this thing. See, this is halogen. Halogen in gaseous form. You know, fluorine and chlorine. If we compare them, fluorine is a gas, chlorine is also a gas. So X2 gas, half of X2 gas plus electron to give X negative aqueous. This is the case, and that will determine the oxidizing behavior. Okay, so half X2, first it is converted into X gas. So what is required? Bond dissociation enthalpy. What is required? Bond dissociation enthalpy. Now X gas is converted into X negative gas. Energy involved is electron gain enthalpy, and last one, X negative to X negative aqueous, means X negative is surrounded by water molecules. See, because you know water is polar, so X negative aqueous, what it means, that you know water has structure like this. O is more electronegative, hydrogen is less electronegative. So H is attracted towards X negative and O is away from it. Like this, H is positive, O is negative. Right? So in this way, X negative aqueous, that means amount of enthalpy change, here it is called hydration enthalpy. What it called? Hydration enthalpy. So say this reaction is favored by low dissociation enthalpy, because if dissociation enthalpy, bond dissociation enthalpy is low, then it can be easily formed. Second, more negative electron gain enthalpy, and third is high hydration enthalpy. Okay, these are the factors which favors the oxidizing behavior of the halogen, fluorine or chlorine, whatever it is. Okay, so first tell me, dissociation enthalpy of which is less, fluorine or chlorine? Yes, madam. Out of fluorine and chlorine, which has low bond dissociation enthalpy? Out of fluorine F2 and Cl2, which one has low bond dissociation enthalpy? What is bond dissociation enthalpy? Amount of enthalpy or amount of energy required to break 1 mole of bonds. How much energy is required to break 1 mole of bonds? So which one has low value? Yes, tell me. Okay, thank you, Aditya Mohanty. Now tell me, yes, beta, tell me, out of FF and ClCl, which one has low value of bond dissociation enthalpy? See, each part is a question in itself. This may be the question, कि why bond dissociation enthalpy of F2 is less than that of chlorine. So I gave you answer. FF has low bond dissociation enthalpy than ClCl. Why is it so? Because of extremely small size of fluorine, there is large inter-electronic repulsion between the non-bonded pairs. What I said? Fluorine F2 has low bond dissociation enthalpy because of its exceptionally small size. Because of its exceptionally small size, there is large inter-electronic repulsion between non-bonded pairs. See, because fluorine is very small in size, therefore these non-bonded pairs, they are very close to each other and therefore they repel each other and gives favorable condition for its breaking. So less amount of energy can break it. But in Cls, chlorine is large in size, so these lone pairs can comfortably placed. Right? That's why bond dissociation enthalpy of fluorine is less than that of chlorine. So this factor is in favor for this reaction. So low bond dissociation enthalpy favor fluorine. Now come to electron gain enthalpy. So electron gain enthalpy of chlorine is more. Electron gain enthalpy of fluorine is favored here. Chlorine is favored by more negative electron gain enthalpy. Negative electron gain enthalpy of chlorine is more than fluorine. Reason is same. Because of exceptionally small size of fluorine, there is large inter-electronic repulsion for the added electron. The electron which is added to fluorine, that feel more repulsion. That's why electron gain enthalpy of chlorine is more. Okay. Now come to hydration enthalpy. You know, out of fluorine, fluoride ion and chloride ion, fluoride is small in size. It has high charge density. So attraction for water, there is ion dipole interaction. What is this? This is fluoride is ion and water is dipole. So there is ion dipole interaction. And due to this ion dipole attraction, energy is released. And the energy released when this ion interact with water, when 1 mole of ions interact with water, that is called enthalpy of hydration, or simply hydration enthalpy. So hydration enthalpy of fluoride is more. So this value favors fluorine. So we will write, because of the low bond dissociation enthalpy and high hydration enthalpy of fluorine, fluorine is stronger oxidizing agent than chlorine. So what it means? Simple meaning, if you would like to write in one sentence, you will write the factor which is not favorable, that you should not mention. Only the factor which favors it, that you should mention. Okay, means fluorine is stronger oxidizing agent than chlorine. F2 is stronger oxidizing agent than chlorine because of low bond dissociation enthalpy of fluorine and high hydration enthalpy. Because of low bond dissociation enthalpy and high hydration enthalpy. So this is the right answer for it. Done? So this is question number 15. Now come to question number 16. Fluorine exhibits only -1 oxidation state whereas other halogens exhibit +1, +3, +5 and +7 oxidation states. Explain. Very simple question. We have discussed it already. Fluorine has only -1 oxidation state, but rest of the elements can exhibit +1, +3, +5, +7. Okay. So, reason for fluorine first. Fluorine is most electronegative. First and foremost thing, fluorine is most electronegative. Okay, and at the same time, it has no vacant d orbital. And after gaining one electron, it acquires noble gas configuration. It acquires noble gas configuration. That's why first it is most electronegative. Second, it has no vacant d orbital. First, fluorine is most electronegative. Second, it has no vacant d orbital. And after gaining one electron, it acquires noble gas configuration just like other halogens. So that's why it exhibits -1 oxidation state only. Because if it can form bond, obviously it should gain one electron, so it can share with other element. So when it share electron, whichever element is attached to it, that should be less electronegative than fluorine. That's why fluorine has -1 oxidation state and the element attached to it has +1. Means given by one fluorine as a +1, other fluorine also +1, like if we have HF symbol. So fluorine is -1, hydrogen is +1. If we have ClF3, then fluorine is -1 and chlorine is +3. We have BrF5, fluorine is -1, bromine is +5. IF7, fluorine is -1 and iodine is +7. That means other halogens, bromine, chlorine, iodine, can exhibit +1, +3, +5, +7 oxidation states, like in ClF. But fluorine cannot exhibit. Why is it so? What is special in other halogens? What is additional in these halogens? so that they can exhibit plus oxidation states, because they have yes, they have vacant d orbital. Other halogens have vacant d orbital, means they are ns2, np5, ns2, np5, and day 0. So if one electron is, so in this condition it can exhibit +1 or -1 oxidation state, means if this halogen attached to other element, any other element, if that is more electronegative, then it will acquire +1. If that element attached is less electronegative, it will acquire -1. Right? For the other halogens, they have vacant d orbital. Okay? In case of fluorine, if it is attached to any other, so that should be less electronegative. That's why it will acquire -1 only. But for chlorine, bromine and iodine, if it is attached to less electronegative, then it acquires -1 state. If it is more electronegative, then it acquires plus oxidation state, +1. So -1 and +1. But in next case, if one electron is excited to Nd, then it can share 3 electrons. So now it can show +3 oxidation state. Or if one more electron is excited, it can show +5 oxidation state. One more electron, then it can show +7 oxidation state. Like we can say ClO negative, ClO2 negative, ClO3 negative, ClO4 negative, or you can write HClO, HClO2, HClO3, HClO4. Now see the name. The one HClO3 is called chloric acid. So if one more oxygen is added, then it becomes perchloric acid. So one oxygen is added to HClO2, it is called chlorous acid. And this one is called hypochlorous acid. See the naming. Chloric is HClO3. Just remember this. If one oxygen is removed from it, it becomes chlorous. If one oxygen is removed from chlorous, it becomes hypochlorous. If one oxygen is added to chloric, it becomes perchloric. So, ic in the anion, it becomes 8. It is perchlorate. So, it is chloric, so it becomes chlorate ion. Chlorus, so it is chlorite ion. See the naming. If it is us, it becomes ite. If it is ic, it becomes 8. Hypochlorous, hypochlorite. Same, see, HNO3, nitric, HNO2, nitrous, nitrate, nitrite. Okay, leave it. I mean to say halogens exhibit +1, +3, +5, +7. Why? because they have vacant d orbital, so their electron can be excited to next level, means can be excited to Nd. But in fluorine, this is not the case, because in fluorine there is 2s, 2p, 2d does not exist, and it is the most electronegative element. That's why fluorine can exhibit only -1 oxidation state. That's it. Okay. Question number 17. These namings are also very important, beta, because sometimes question is what is the oxidation number of chlorine in a perchloric acid. So you should know the formula of perchloric acid, otherwise you are not able to do it. Okay. Next question. Question number 17. Write the balanced chemical equation. Write the balanced chemical equation for the reaction of Cl2 with hot and concentrated sodium hydroxide. Next question is this reaction a disproportionation reaction? Justify. Okay, so say write the balanced chemical equation for the reaction of chlorine with hot and concentrated sodium hydroxide, and is this reaction a disproportionation reaction? Justify. So first of all, what is disproportionation reaction? So disproportionation reaction is one in which the same element gets oxidized as well as reduced. Same element gets oxidized as well as reduced. So say we have chlorine with concentrated sodium hydroxide. So it will give NaCl plus NaClO3 and H2. If it is dilute sodium hydroxide, we will get NaClO. So what is the name? Sodium chloride. And what is this? Sodium? Yes, sodium chlorate. Just we have done. It is sodium chlorate. Okay, because it is ClO3 negative. Now, oxidation number of chlorine here is 0. In this NaCl it is -1, and in NaClO3 it is +5. So from 0 to -1, 0 to +5. That means chlorine is reduced, chlorine is oxidized. So this is a disproportionation reaction. So how do we balance it? Just note down. How do we balance it? First of all, you should write two chlorines. One chlorine which is oxidized and other chlorine which is reduced. Whenever disproportionation reaction is there, you will write the element which is oxidized as well as reduced 2 times. So it is converted to NaCl. So Cl2 from 0 to -1. And Next is NaClO3 plus 5, 0 to plus 5. So just let it be half, because there is one chlorine, otherwise you will double it. Okay, it is up to you. Okay, I will keep it half. So 0 to -1. So there is decrease in oxidation number by 1. 0 to plus 5. So increase in oxidation number by 5. Decrease in oxidation number by 1. Increase in oxidation number by 5. Okay, so multiply it by 5, just because, so that decrease in oxidation number is equal to increase in oxidation number. That we should balance the charge or oxidation number. Okay, so if we multiply it, it becomes 5 by 2 and 5. Sorry. 5. Okay, so 5 by 2 plus Cl2, so it becomes how much? 5 by 2 plus half, so it becomes 3 Cl2 plus, say, sodium hydroxide has no role to play, so it is just to balance sodium and oxygen and hydrogens. So 5 NaCl and 1 NaClO3, so it becomes 5 plus 1 6 NaOH, and 3 oxygens are utilized here, 6 hydrogen, 3 oxygen, so 3H2. So in this way we can balance it. We have balanced it simply by using sodium hydroxide, because it is given to us. If it is not given and it is written that medium is basic, then what we do, we add H2O to the side excess of oxygen. See, 3 oxygens are there, so 3 H2O to the side excess of oxygen, equal number. Okay, and double OH negative ion to the opposite side. So double OH negative means 6 OH negative. Sodium we can see here, so sodium hydroxide, right? So this is it. Okay, so we have justified that it is a disproportionation reaction, and just see this equation. If it is dilute, this is very important. Cl2 in concentrated NaOH and Cl2 in dilute NaOH. If it is dilute, it becomes NaClO. This is the only difference. Instead of NaClO3, we get NaClO, means sodium hypochlorite. If it is dilute sodium hydroxide, again this is a disproportionation reaction. Okay, next one. Question number 18. When HCl reacts with finely powdered iron, it forms ferrous chloride and not ferric chloride. Why? question is, when HCl reacts with finely powdered iron, it forms ferrous chloride and not ferric chloride. Why? So see, Fa when comes in contact with HCl, we get FeCl2 along with H2 gas. So actually H2 being a reducing agent, so it prevents further oxidation of FeCl2. It prevents, H2 being a reducing agent, it prevents further oxidation of FeCl2 to FeCl3. So keep in mind, because of the production of hydrogen gas, further reduction is not possible. Further reduction of FeCl2 to FeCl3 is not possible. If you know, when oxygen and moisture is there, corrosion of iron, so Fe2O3 we get, because there is oxygen, and you know oxygen is a reducing oxidizing agent, so that can oxidize iron to +3. But here when HCl is reacting with iron, we get ferrous chloride along with hydrogen gas, and hydrogen gas is a reducing agent, so it has ability to reduce rather than oxidize. That's why it prevents further oxidation of FeCl2 to FeCl3. That's it. Now question number 19. Deduce the molecular shape of BrF3 on the basis of Vesper theory, valence shell electron pair repulsion theory. So we have to deduce the shape, molecular shape of BrF3. So you know, in BrF3, when we apply Vesper theory, you know, 3 fluorines are attached to bromine. So it has, BrF3 has 3 bond pairs, or we can write completely that 3 bond pairs. Now each fluorine can share 1 electron, so 3 electrons of bromine are shared, and you know bromine has total 7 valence electrons. Every halogen has 7, so bromine has 7 valence electrons. Bromine has 7 valence electrons. Out of 7 valence electrons, 3 electrons are shared with fluorine atoms, with 3 fluorine atoms. So 4 valence electrons left unshared. So it has 2 unshared pairs. So it has 2 lone pairs. That means BrF3 has 3 bond pairs and 2 lone pairs. So total 5 electron pairs are around the bromine. So 5 electron pairs are arranged in trigonal bipyramidal geometry. So see, there are 2 lone pairs. So lone pairs are always on equatorial position. Yes, they are on equatorial position, and fluorine bond pairs are on axial. Now say they are slightly bent because these 2 lone pairs repel them. These 2 lone pairs repel bond pairs. So as they repel, so because of that repulsion, these bond pairs are slightly towards this bond pair, and that's why shape is bent T shape. Say arrangement is trigonal bipyramidal. Arrangement is trigonal bipyramidal, right? But due to the presence of 2 lone pairs, these bond pairs are slightly bent, and therefore, because lone pair bond pair repulsion is greater than bond pair repulsion, and that's why it is bent T shape. So shape of BRF3 according to Vesper theory is bent T shape, right? Yes beta, any doubt up to this? Yes Manjot, Anika, anyone out of you? Vinay, Aditya, Monica, Abhay, any doubt beta? Any doubt up to this? Okay, so question number 20. Question is, why are the elements of group 18 known as noble gases? Why are the elements of group 18 known as noble gases? So I have already told you that group 18 elements, electronic configuration, first of all write the electronic configuration. So electronic configuration of group 18 elements is NS2 NP6. They have fully filled electronic configuration. They have fully filled electronic configuration. That's why they are least reactive. They are least reactive, so they are known as noble gases because they are least reactive. They are not totally inert, but they are very less reactive because of fully filled electronic configuration that has extra stability. You can write that as well. That's why they are least reactive. So they are called noble gases. Simple. Next question. Noble gases have very low boiling point. Question number 21. Noble gases have very low boiling points. Why? So question is, noble gases have very low boiling points. Why? Again, same reason. They have very, because they cannot form bonds. Okay, so they have very weak van der Waals interaction, means intermolecular forces of attractions are very weak in noble gases because they are not forming bond easily. Okay, and that's why their molecules, means simple atoms, okay, they have very weak van der Waals interactions. That's why their boiling point is low. Done? Samardeep Singh, merit quiz. Okay. Sure, beta. After this question, last question, and then I will ask one quiz question. You have given me this idea. Thank you, Samardeep Singh. Okay, so question is, last question 722. So total 22 in-text questions are there in P block. Question is, does the hydrolysis of XeF6 lead to a redox reaction? Yes. Does hydrolysis of XeF6 lead to a redox reaction? So see, if XeF6 is completely hydrolyzed, then we get XeO3 and HF. So they will give like this. XeF6 give XeO3 along with HF. So in XeF6, oxidation number of xenon is +6. In XeO3 even it is +6. Right? But if they are partially hydrolyzed, XeF6 is partially hydrolyzed. So either we get XeOF4, means 2 fluorines are replaced by 1 oxygen, because oxygen is divalent, fluorine is monovalent. See, 6 fluorine, 3 oxygen. So 2 fluorines are removed by 1 oxygen along with 2 HF, or XeF6 plus H2O to give XeO2F2. 2 oxygens are added, 4 fluorines are removed along with 4 HF. So this is the case. So in this case, see, xenon is +6, but here xenon is again +6. In XeF6 even it is +6, again +6. That means hydrolysis of XeF6 is not a redox reaction. On complete hydrolysis or on partial hydrolysis, XeF6 oxidation state remains same. That's why it is not a redox reaction. So let us have this merit quiz. So question for you is, so Cl2 with concentrated NaOH will give NaCl plus something plus H2O. So what is this? When chlorine react with sodium, concentrated sodium hydroxide, what is this blank? What I feel here? Yes, fast. Quick reply. Thank you, Simardeep Singh. Yes, what I feel here? It is concentrated sodium hydroxide. Fast. What I write here? Yes, it should be NaClO3. Okay. Why not others are replying? If we have dilute NaOH, then we get NaCl plus NaClO and water. So thank you so much to all of you. So do like, subscribe and share my channel, and please do share with your friends so that our subscriber count will increase and I will reach at the top just like other fellows who are in this field, and they have so many subscribers. I don't know how. I don't have. I do agree there is some sort of things which I am not doing. So after your suggestions, your comments and suggestions are most welcome. Please do suggest me what to do to increase my subscriber count and flourish my channel to grow it to next height. Okay, so please do share with your friends. Thank you so much. God bless you all. See you tomorrow at the same time, that is 8 p.m. to 9 p.m. There is a daily class from 8 p.m. to 9 p.m. for this CBSE board exam, and 9 p.m. to 10 p.m. Same, I will share with you that part also. On Noon app, I am taking NEET revision for class 11 for next 21 days starting from tomorrow at 9 p.m. to 10 p.m. This is a live class again on the Noon app. It is absolutely free, no hidden cost. You can just join Noon Academy and just say, write NEET Chemistry by Suresh sir. I will share the link as well in the description, so that you can join it easily. Okay. So in these 21 days, we will revise whole 11th, especially organic, states of matter, basic concepts of chemistry. Okay. Even small chapter like hydrogen, S block, some P block elements, whole inorganic, organic, and some part of physical. Okay. And for next 21 days, we will revise 12th. Means most of the lectures are on organic chemistry for class 12th. So that will help you to prepare for NEET exam. So you can join it. Just download the Noon app, sign up, and join my group. So I will see you there on also. Okay. So all the best, guys. Thank you so much. God bless you all. Bye bye.